In today's lessons, we're going to be focusing on concepts like lerping and tweening, which are universal to all sorts of game engines and development tools. We're then going to talk about coroutines, which are a Unity-specific feature to make lerping and tweening a little bit easier. We're going to talk a little bit about sprites and the 2D systems inside Unity, which will set us up to talk about particles. And with particles, we'll put all of it together and make a neat little scene where we shoot some particles at a target. So, what we're going to start with is lerping. Now, lerping is a neat little vocabulary word, and it stands for linear interpolation. So we have lerping, and this just stands for linear, interpolating, interpolation, etc. Okay? And so, let me zoom in a little. Alright, so linear interpolation is basically saying we have two values, okay? We have a value A and a value B. And we're going to say A and B is a range from 0 to 1, okay? And we have some value on this range called T, our interpolated value, whatever. Okay, it's basically what we're doing is we're mapping from the range 0 to 1 to the range A to B. So we're kind of getting a proportion to some extent. Now, this lerping function is most commonly used for something called tweening. If we were to move this value t over time, we're essentially going through this range, A to B. And since it's this normalized value, which is something we talked about in the past, it's a value that we've represented from 0 to 1, sometimes negative 1 to 1, because it is a multiple of 1, we can scale that to any number of ranges. So this lerping function, okay, you're going to see this in lots of places. Unity gives us some shortcut functions, but what you're normally going to see is you're going to say, like, your lerp value, right, your interpolated value is going to equal A plus T, which sometimes is a percentage. I usually see this generically called a T value, and that's going to be times the range itself, okay? And you can increment T over time, and you essentially move this whole lerped value. And so, for example, let's say A is 0, okay? B is 10. We'll say T is equal to 0.2. So T will be between 0 and 1. Sometimes it'll be a percent, so 0.2, 20%. If we want to do it, we can plug this in, right? We get 0 plus 0.2 times 10 minus 0, which is just 2. Okay? And so if we had a range A to B, we could represent this, we could represent a lot of values just with this T value, lerping, and we don't care what A or B are, we can always talk about these normalized values. And you can use one T value in multiple different ranges and save so much different time. And again, moving this T value is going to be how you do tweening, which if you're an animator, it's how you do almost anything. It's in between. You can do it really easily with a computer because you can linearly interpolate from point A to point B. So drive this point home. Okay, so A is equal to 0, it's the T-vals, and B is equal to 1, okay? And everything in between gives you a value between A and B if it's plugged into this lerp function. Okay, so this lerp function doesn't care if these are numbers, these could be vectors, they could be colors. It's all the same so long as it's a mappable range, okay? You can represent any linear range by going between a point A and a point B and mapping that from 0 to 1. So this idea of lerping is really important. So I have this Unity project up, and I've got a couple of assets already in this, but we'll talk about those later. And I'm going to go ahead and create a couple things for us, alright? I am just going to start making a 3D sphere. Alright? And just to show you guys a little bit more about normalized values, I'm just going to move this guy left to right, okay? And I'm going to do that by just doing some basic math. Okay, so let's make sure that the sphere is more or less in the middle of the screen. Alright, you can see it's at 0, 0, 0. And so I'm going to create a scripts folder. Alright, and inside here I'll just call sine wave. Alright, and what I'm going to do is I'm going to move the sphere based on a sine wave. Let Visual Studio boot up here. And so a sine wave, okay, you know, sine wave is just our, sine wave, we have a line, and we go whoop, 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 right? And then the sine wave goes from 1 to -1. Highly scientific diagram. You get the idea. I am no illustrator. Holy cow. Alright, well, anyway, so a sine wave. We can multiply that normalized value by some speed, and we can functionally move any value. We can toggle it between two endpoints, right? So, if I say, I'm going to make a public float so that I can use this in the inspector, power, and I'll just say 10f, okay? So we want to move this left to right 10 meters a second, okay? Not going to do anything in start, so I'll just go ahead and delete that guy. And inside update here, I'm going to get a couple things. First, I want to get start position, which will be this.transform.position, right? This gets me a vector 3. And I am going to want to say start position.x, alright, plus, equals start position.x plus power, sine, math f, excuse me, that's sine, alright, so this will give us that sine function, times time dot time since level load. So the sine function, as some value goes up extraordinarily high, it's always going to bounce between -1 and 1. And I'll just multiply that times power. Actually, I am just going to leave this. I know it starts at 0, so I can do that. I'm going to go back to Unity, okay? And I'm just going to drop this onto my sphere. Let me hit play. Give it a second to compile. Oops. Okay, see? I always forget to do stuff like this. I'm going to say this.transform.position equals start position, so I've modified it. I need to actually set it back to the variable. Let me go back. Alright, so you see, there we go. And since it's a curve, you can actually see it ease in and ease out. So this is a really quick way to make a pendulum effect. But as you edit this power, right, you can see that it goes much slower. And this just illustrates how we're just manipulating a normalized value to move something by some power. Okay? So the math gets more complex as you want to do more and more things, but it's really important that you start thinking about normalized values. And this is the basis of lerping. Okay? So now, what if I want to move from point A to point B? Okay? What if I want to move 10 meters up in X amount of time? How do I do that? Okay, that's what lerping gives us, right? So let's sketch this guy, okay? So here's my sphere, alright, and I want to move up 10 meters, so this is 10 units in Unity, in, let's say, 5 seconds, okay? So what I'll need to find is point 1 and point 2, okay? And so we'll say 10 meters is D, right, and 5 seconds is T. And we're going to say point 1 is the ball's position, right? And then point 2 is equal to the ball plus 10 on the Y, right? So 0, 10, 0, if we're talking about 3D space. Alright, and so we have our A and B's, right? If we're going to lerp. So A is point 1, and point 2 is B. So A, B. And again, these are values we're going to map from 0 to 1. Okay? So now I want to animate my T value, or modify my T value. Okay? We're going to say T equals 0, and after 5 seconds, T is going to equal 1. Okay? So let's very briefly just make a new script. Okay, I'm going to remove this guy, and we will call this, what do we want to call this? Tween up. Tween up. Or we'll call it basic move tween, okay? Because that's what we're going to do here. If we eventually animate this t value, we're doing a tween. That's exactly what we're doing. And so in this one, we're going to have a duration, okay, which we said 5 seconds. And for now, we're just going to say public vector 3 offset, how far we want to travel, okay? And we know that this is going to be, by default, 0, 10, 0, okay? So let's go back here. Those guys compile, and if I attach this, you can see, I don't think we've done this before, but since I had a public vector 3, I can actually manipulate each of these, and these are values I'll be able to store and access inside my script. So what I need to do is make some private, okay, variables here. I'm going to have vector 3 start position, and I'm going to say this, I can leave that alone, and I also want a vector 3 target position. By the way, if you ever don't get the syntax highlighting, sometimes all you need to do is reload the script. Or restart Visual Studio, even. It's even better. And it's just always helpful to have the auto-completion. I have a couple settings that make this pretty annoying. Okay, there you go. So, there you go. We get vector 3 in green. And now it'd be easier to use the autocomplete. So, in start, okay, we could use awake, but I'm going to do this in start, just so I don't have to type a bunch of stuff. I'm going to say start position is going to equal transform dot position, okay? And the this is implicit, but I'm going to go ahead and type that in. It's a good idea to type that in to always be explicit. And then the target position is just going to be the start position plus the offset, which we've said is 10 on the Y. Okay, and to illustrate this, I'm just going to go ahead and make a public float t value. I'm going to set this to 0. And this is something called a property drawer, but you see how I can mark this up here? I can say 0f, 1f. I'm going to make a range, alright? And now, what this says is, like we had with duration, right? I could type in any value. Now, well, let me show you. I'll flip back here. Let me click on the sphere, and you see, look at this. Now I have a slider here, and that's because I put this range property drawer. There are all sorts of property drawers, and if you're interested in them, just Google property drawers Unity, and you will see a lot of stuff about them. Range is the one I use the most often, so I say range, minimum to maximum, and it's very easy to make sliders that way. So if you're coding something that you want your designers to easily be able to edit, it's a good idea to start using things like range. Anyway, so in update, what I want to do is get my lerp value, okay? And there's a bunch of ways I could do this. So first, I'm going to do it with our lerp function that we talked about here, okay? And we'll say lerp equals a plus t times b minus a, okay? So we know b is the target position, and we know a is the start position, and we know t is our t value. And that's a value we're going to manipulate in the inspector. So we're going to say transform.position is equal to start position plus tval times target position minus start position. Alright, and since these are vector 3s, I can add and subtract them from each other, and I can also multiply them by floats. Okay. So I will bring this guy back down to 0. Now if I hit play, look at that. Okay, so now it is just moving between 0, 0, 0, 0, and 0, 10, 0. So you can see I have position x is 0, y is 10, and z is 0 when the t value is 1, and it's 0 when it's here. So this is just to show you that the math works, okay? This lerp function, you should memorize. you will never need to use it inside Unity, but it's something that if you ever are going to code your own gaming functions, maybe someday your own engine, you never know, you're going to need to use this at some point. Now, Unity gives us a lot of things we can lerp, alright? Like I said, this is the lerp function, the linear interpolation. So I can replace this. Vector3 has a built-in lerp function, for example. Okay? It floats also. So I'm going to start with the float. So instead of doing this function, okay, I'm going to say new vector3 0, and I'm going to be lerping the y, right? I'm going to say this is mathf.lerp. Okay, and you see we have a, b, and a t value. So we know our a is going to be 0, and we know our b is going to be offset.y. And our t value is going to be t value. Okay, so we can do this with a simple float, and we get the same result. You know what, let me go ahead and put this down to a lower value. Alright, and it's completely linear, right? So as t moves forward, it moves linearly from A to B. That just means it moves at a constant rate. Whoa, nope. Didn't mean to save it quite yet. There we go. That's really easily visible. Okay, so we have doing it with a simple float. We can also do it with vectors. So instead of doing this, instead of interpolating the y component, we can interpolate the whole vector. So in this, we'll say vector3.lerp. Okay? And you can see as I type this in here, it says linearly interpolates between two vectors. Our two vectors are our start position and our target position. And we'll say tval for this. Okay? Great. So, now if I go back, we'll have the same result. Alright, that's kind of super exciting. And again, as I change this offset, right, now, the reason this isn't happening is because I only calculated this in start. So if I want to be able to change this at runtime, okay, and doing these extra little math calculations is not a big deal. I've seen some people get nervous when they start doing a bunch of extra addition or something in an update. You generally don't need to worry about that. What you want to avoid is making brand new objects every frame. So in update, we're going to say target position, once again, is start position plus offset. We'll just do it again. And we don't actually really need this here now, so I'll go ahead and delete that. Alright, I'll pump that up to 1, and you can see now that it's at 1, I have negative 5, 5, and look at that, it's moving along a diagonal. So, that's pretty neat, okay? So, like I said, this is linear, alright? So, as A goes to B, it's happening in constant rate. So, let's say I want to animate this a little bit. Let's move the t value and update, okay? So, instead, I will just fluctuate this based off of a sine value, okay? So I'm going to go ahead and make this guy private instead of public, okay? I'm going to set tval to 0 at the start, and I'm going to say tval is equal to mathf. I'm going to use the sine function we used before of time.time since level load. Okay, just to show it happening again. And what we're going to see here is something a little different. Okay, so why is it stopping at 0? That is because it is clamping the value. So Unity's built-in lerp functions actually usually have a clamping option. And the reason this is happening is if I open up my lovely sine wave again, right? Every time for the time, that the t value is above 0, right, the object's moving, okay? That's why we get that nice up and down motion. But for every time it's down here, it's getting clamped, okay? And so, our t values, okay, so if we have our lerp line, okay, a b 0 1. What happens if we have a value greater than 1, right? Well, there's two things that could happen. We can clamp the values, or we can just let the function have its day. So we can let the lerp function calculate. So by default, that vector3.lerp clamps it, and clamping just means, you know, if t is greater than 1, t equals 1, right? And else if t is less than 0, t equals 0. That's just some pseudocode. So now if I go back here, right, I start, see this, I have this lerp unclamped function. Now we'll get like a pendulum. And there you go. So I am going to do a couple more things. So instead of doing this by a sign, what if I want to do it over time, okay? I need to do some math, alright? We know duration is 5f, okay? And we're going to do this with another interpolated value, okay? But we're going to inverse it this time. So this time we want to calculate the t-val, alright? And we have our lerp equals a plus t times b minus a function, right? Okay, and what we're going to be doing is changing our actual value, and our start values are going to be 0 and duration. So instead of doing it with a vector, right, we're going to say 0f, right, our elapsed time, okay, is going to be 0f, which is a, plus t times duration minus 0f, right? And so this means in elapsed time, if we solve for t, we're going to get an inverse. We're going to get the t value from the range. It's just solving for t in this function. And then we'll plug in t-val here. Okay? And so, you know, I'm going to go ahead and make this guy public again so that we can watch it happen in the inspector as well as watch the sphere move. But anyway, so I'll do this with the math first. Okay? So I'm going to make a float called elapsed time. Okay? I'll set this to 0. I'm going to make it public so that I can redo this while the game's running. Start, I'm going to say elapsed time equals 0f. And then I'm just going to say elapsed time, okay, plus equal time dot delta time. Okay? And now, if I solve for t in this function, right, t-val is just going to equal elapsed time divided by duration. Okay? And I could clamp this, but I'm not going to clamp it so we can see what clamping's doing. And I recalculate target position, and vector3 lerp unclamp, start position, target position, and t-val. So let's go ahead and do this. So now this is going to move it from 0, 0, 0 to 0, 5, 0 in 5 seconds. And it's going to keep going because I didn't clamp it. But you can see this t-val goes past 1. Right, elapsed time keeps going up. So if I set this to 0, see it goes back down. That's because it's recalculating the t value. And what if I set this to like -10, right? It's still going to work. It's just math. You can do so many of these neat little move from A to B just with the most basic mathematic equations, and there's no sense in being like scared of it. So if I want to clamp this, right, I could clamp it here, or I could clamp the t value. So if I want to clamp the t value, I can clamp floats really easily, okay? I can say mathf.clamp, and I have a shortcut. For normalized values, which I've mentioned are some of the most common things you're going to be using when we talk about lerping or tweening, you can see I have clamp 0, 1, which just says it clamps the value between 0 and 1. I also have clamp, where I could give it a value, which is elapsed time divided by duration, and then a minimum and a max. So if I wanted to clamp it to a different range, I could do that. I just want to do this. Okay. And that's it. Okay. So now it'll stop when it gets to 5. Elapsed time will keep going up, though, but the t-value won't go any higher than 1 because I've clamped it. So, we've talked about doing it linearly, okay? And so when we do a linear interpolation, okay, what we've said, okay, so we actually have a graph, okay? We've made a curve when we tween. And when we tween with a lerp, it's a linear curve. So we've said go from point A to point B, alright? But we said do it over time from 0 to 1 in time too, right? We just lerp the time, and then in distance traveled from 0 to 1. And we've said go this way, okay? And so this is A, and then this is B, right? This is our that's our target lerp, and then this is kind of our time. So we'll say t of 0 and t of 1, right? T of 1 being our duration. Okay, and so we have a linear curve, meaning that when t is equal to 0.5, this when time is equal to 0.5, our L, our lerp value, is also equal to 0.5, okay? That means whatever's here is mapped directly into the range A to B. But we can have different kinds of curves, okay? And if you're an animator, you've seen some of these. We can have ease in, ease out curves. Something like that. There's a whole bunch of different things. You know, this will be a speedy in, speedy out kind of thing. And let's see if I can just do a quick Google search here. We'll say tween curves. Alright, easing functions. That's what these are, basically. I call them tweening curves, but you'll call them easing functions a lot as well. And these are super common, okay? You don't need to memorize all of these. These aren't built into Unity in any specific way. But we can use animation curves with linear interpolation. And here's how we're going to do that, okay? We have this function, right? We want to get the t value for the range A to B. So we want t for A to B, okay? So that we can get the proper position that we want. When we do it linearly, the time is going to equal this t value, right? And writing this out now, I finally see why some people don't like to use t. It gets kind of confusing when we're talking about time as well. So percent, we want the percent for A to B, really, and at time, okay? And so if we look it up in a linear curve from 0 to 1, right, we'll get the same thing we put in. But if we look it up in a curve like this, well, we'll get something completely different. We'll get whatever's here. And in Unity, we have easy access to this. There's something called an animation curve. Alright, and I can make this a property of my script. I will say public animation curve. Alright, and I will call this t-curve or tween curve, whatever you would like to call it. I'm not going to give it a default value, but you typically will want to give it a default value. And look at this. Now I have this new fancy thing in my inspector here for basic move tween. Okay? Look at this. Alright, and I click on it. Alright, and see, I get this little graph editor. And you can see I have 0 to 1 and 0 to 1. If I click this, okay, I have the same thing. This is the exact same as a linear interpolated curve. So I hit that and I hit save, okay? And I let this play. Alright, you know what? I'm going to bump this down to 2. I'll set this to 0 again. Alright, and I just keep resetting this. You see, it's linear. Alright, so what I'm going to do, though, is I am now going to set this to an ease in, ease out guy. Set this back to 0. Oop. This is because I haven't plugged it in. Sometimes, man. Sometimes I just don't think about what I'm doing. Alright. So I need to look up the value on the animation curve before I do it. Okay? So just changing the curve like I did there did nothing. Because I haven't plugged it into anything. And what I want to do is I want to actually set tval to something, to itself. It's going to look kind of weird, but I'm going to say tcurve.evaluate. Alright? And I'm going to give it my tval. Alright? And if I open this graph again, right, evaluate means time, give it a time between 0 and 1, and then it will give me a value in the curve. So, since these are all normalized values, I can just give it a normalized value and look it up. It's kind of a cheat, but you're actually going to see this, you know, we could have just as well have plugged this into the equation for this line. Udemy just gives us a nice visual editor. So you'll see these easing functions, okay, and that website I had popped up, you know, I think you can click on these guys and it actually will, I think at some point you can actually get the actual function itself, though this is for web development. Anyway, so now, if I hit play, look at that, you can see it was slow to start, and then it's going to slow down. It should have slowed down before it finished. But, there you go. See, it definitely gets off to a slow start. And now, we can do really bizarre things with our curve, though. Like, we can say, so this should travel, like, up and then back down. Right? It's following a really bizarre curve. And so, without changing any code, we can make all these neat little modifications just to move something from point A to point B. Right? We can have these linear steps, and this will be weird. This will move up, and then teleport down, and then when it gets to 5, it's going to teleport back up. So the reason I want to talk about animation curves is because you should be able to read animation curves. You should be able to look at this curve and understand the motion that it's doing. So just by plugging this in, okay, right, we can see that it eases into that motion. And that's really powerful when we're describing motion, when we describe how things move. There needs to be some sort of syntax and code to describe that. I can tell you that it eases into it, but it's another thing to say that in code, and we do that with curves. We could do that with functions if you're really good at reading math, but I think just about everybody would rather read a curve. So instead of doing it with this offset, though, let's parameterize this even more, okay? Let's say we want to do, what's the word? Using some of the lessons we learned last week, instead of giving it an offset, okay, we could say public transform target, okay? And now we're going to say the target position is just going to be the target dot position here, okay? We're not going to use that offset at all, because we don't need to. We're just going to calculate it from the transform. So I'm just going to get rid of this offset. So now, let's make a 3D object, a empty one rather. We'll say tween target, and I'll set this to -505, okay? And I'm going to plug that into the sphere. I just hit play, alright? So now it's moving to my tween target. And I can move this away, I can move it around. And again, as my thing goes from 0 to 1, you know it's gonna have this issue, so just go ahead and plug that back down to 0, and we can see it move around in 3D space. So this is just the most basic way to move stuff from one point to the next. Okay, so I want to, now that we've done tweening, okay, I want to talk a little bit about Raycasts. This is something we talked a little bit about when we did collisions. Okay, and Raycasts are very special. They let us do so many things, okay? And I'm going to come back to this tweening, but for now, okay, I am just going to leave this be, and I'm going to talk about Raycast for a moment. So I'm going to actually go ahead and prefab none of this. I'll just delete it. It'll be easy enough to remake. Okay, and I'm going to need to make a couple things. I'm going to make a 3D object. I'm going to make a plane. Okay, let's 0. And let's move this down on the y a little bit. So -2. And I'll scale this up so it's a little bit easier to see. And what we're going to do is we're going to move an object around, okay? I'm going to say we're going to move a cube. We're going to make a very, very basic Rts controller. Okay, so let me position this camera somewhat like an RTS. So an RTS being a real-time strategy where you'd have more of an overhead view. We'll say like 30 degrees. Okay, and great. I guess there's no reason to hit play. Let's make a material for this cube, and we'll make it red. Okay, so now if I hit play, alright, I can see that guy just fine. Okay, and we'll call this guy RTS mover. Alright, so alright, didn't open the script. Goodness gracious. Oh, I was clicking the wrong thing. Goodness. Man. Alright. So we're going to make a public transform target, or unit. Let's call it unit, in the spirit of an RTS. And I've got this thing happening again. Okay. Alright, I'm going to restart Visual Studio, let that happen, and I'm going to talk about Raycast, okay? So, Raycasts. That's it. Alright, we have our camera, okay? And this camera has our projection matrix, okay? And then in our game we have our plane, okay? This, I don't know why I've rotated the whole world, but bear with me, okay? And a Raycast just says, let's draw a line, okay? We're going to draw a line from point A in a direction D with a max distance, okay? So, let's say we want to draw a ray from the middle of the screen. A ray just says we're drawing a straight line, okay? And let's say we drew it in this direction, okay? It's going to draw this line. But a Raycast is going to tell us when it hits anything. So this point of collision will be a hit. It'll be a Raycast hit. And this hit will give us a position. And that position will give us a target for us to move our unit. So if our unit's over here, we know that we want to move it to that point. Okay, and so Raycast can be used for lots of things, right? We can Raycast against objects in our level. It'll be commonly used for AIs to see where they're going. Raycasts are a super important thing, alright? And so we've got our RTS mover, alright, and we've got a target unit, and I'm going to say every frame we want to go Raycast hit. Okay. And not Raycast hit. So, yes, we will want this. This is going to be a little kind of weird code. We're going to say hit. Let that be null. And then every frame we're going to say if physics.raycast. Okay, and the origin will be from the... We're going to want to get a couple things, sorry, here. Origin, and we're going to say the origin is the camera.main.transform.position. So we're going to say it's from the position of the camera, okay? And we will say, sorry, ray equals new ray. Alright. Sometimes it makes these things confusing. So we had to make a couple things, right? Give it an origin, and the direction will be the camera.main.transform.forward. So we're going to go basically right from the center of the camera forward, and we're going to say if physics.raycast ray, okay, comma, max distance, we'll go 1,000 units, okay, and then we don't want a layer mask. Okay, we will say out hit. So there are a lot of different ways to use this function. There we go. Alright, so when you use physics.raycast, you gotta be a little bit careful. But basically, what we've done here is this is a Boolean function, okay, so it's going to return true or false, and if these do hit, right, it's going to return true. And what it's going to do is it's going to stick all the data for the hit in this hit object. This out means we are passing it by reference. If you're a programmer, you hopefully know what that means. If not, don't worry too much about it. Just know that when you want hit information, you need to put the Raycast hit outside of the Raycast call, kind of like this. Otherwise, you won't know where the hit happens, okay? And what I'm going to also do is I'm going to say debug.drawRay, and we can draw rays really easily. We're going to say the start is the origin, and the dir, again, is camera.main.transform.forward. We actually want to multiply this by 1,000 like we do here, and I'll tell you why in a second, but I'm just going to go ahead and hit play here. I'll attach this RTS mover to camera, and I'll make the cube the unit. Okay, you see this white line? That's the ray we drew. Okay, so yep. And it goes all the way through here. And we gave it 1,000 because eventually this line's going to stop. It's going to stop at 1,000 units away. So let me go back to the camera. Okay, man, it's really hard to see, isn't it? I think I can change the color of it. Yeah, we'll say color.blue. There we go. Alright, now it's a lot easier to see. Alright, so we'll get this hit point. So we don't actually really want to do it from the center of the camera, right, because this doesn't move. Instead, we want to transform a screen point into a ray. And Unity gives us a built-in way to do just that, okay? So instead of saying ray equals new ray, we want to set a different origin, okay? In fact, I'm just not even going to bother using that as a variable. I'm not going to need it, and we'll get some errors here for the time being. But instead, I'm going to say camera.main.screenPointToRay, and it's simply just going to give it the mouse position. Alright, and now this ray actually holds the data I want to use for the debug ray, so I'm going to say ray.origin and ray.forward. Ray.direction. Okay, and it'll be 1000F times the color blue. And so now when I hit play, okay, I'm going to put my mouse somewhat to the right of the cube. Alright, okay, look at that. Right, I've got that ray, now that's moving towards where the mouse is. Okay, and put it over here, and I'm going to pause it again. And you can see now it's on the left of the cube. So it's following my mouse, and now we'll put these side by side, and we can watch it in runtime. Okay, great. So now, if there's a hit, I want to do something. I want to get the position the hit's at and move there. I want to move my unit to the point where the hit happens. Okay, and there's a couple ways. Of course, there's always a couple ways to do it. But if there's a hit, I want to move my unit towards where the hit is. So I want to get to 3 unit position is unit.position. Alright. And then we'll say vector 3 target location is going to be hit.point. That is the point where the Raycast hit a collider. And then I want to say unit position, okay, is going to... I don't want to move the y, since I'm going to move across a flat plane. I am actually going to set the, I'm going to set the target location .y to the current position .y, so that I never really effectively change the y. And now I want to say unit position is going to equal vector 3.lerp, okay, from itself to the target position, target location, and I'm going to do this by time.delta_time times a speed variable, and I'm going to go ahead and make this up here, so public float speed, And now, what I've done here with this lerp is I've said I'm going to move from unit position to target location by some factor of speed that's been multiplied by delta time. All this means is that I'm going to ease in naturally to any location I go towards, because what have I done here, alright? What is this lerp value doing? In one frame, okay, let's say we're top down, okay? Alright, we have a, we'll say this is where the cube is, and this is where I'm going. Okay, so in one frame, A is here and B is here. But in the next frame, okay, A could be half as far. And effectively, our t value will stay the same. Our t value will always be time.delta time times some speed. And this just means we're constantly getting slower as we go towards our target location. That's effectively what that'll mean. Okay, and then now I just need to set unit dot position equals unit position. All right. And you know what? What do I do? I'll just do that. Less lines of code. It's always nice. So I believe I put the RTS mover here. Okay, so now I'm constantly going to be moving towards where there's a hit. Okay? And unlike what we did to move the mouse, to move an object to wherever the mouse was on the screen, this is now moving it towards a point. Okay? And I could make this different, alright? What if I only wanted to do it while I'm holding down the mouse? Well, I'd just surround this with input, right? I'd say if input.getMouse button, see if it's down, we'll say 0. If I'm holding down mouse 0 at all, and I'll just go ahead and put this here. Okay, see, nothing's happening, but now if I click down the mouse, yeah, now it follows me. So I could do this to make some pretty nice things, right? And you can see how it actually sort of slows down as it gets towards my mouse. Does a couple weird things. And what's this happening here, right? Let's see. You see what happens when my mouse gets over the cube? Look at that. Now the cube's moving. That's because the Raycast is actually hitting the cube. And so there's a way around that. Okay, and we'll talk about that real quick. There are something called layer masks. Okay, so at the top, I'm going to say public layer mask mask. Alright, and now in this Raycast, okay, let me just go ahead and delete this parenthesis though, so we can get the thing popping up. If I come down a couple things, alright, you can see I can say Ray. Alright, there's a lot of weird things. Alright, so an integer layer mask is actually the same thing as that layer mask I just typed up there. Don't let it fool you. It's fooled me many times. Anyway, okay. So now I'm gonna go back here, and you'll see what I have. Okay, I have this new thing here, and what the layer mask is it is telling me what layers I want to ignore. So we talked about what's the word? We talked about tags before, but there are also different layers. These can be for collisions and for a bunch of other things. I'm going to go ahead and make a new layer, and I'm going to call this ground, okay? Alright, and I'm going to set the plane to the ground layer. And our main camera, the only thing I want to hit is the ground. Okay, so now, you see, now it's not, now when I go over the cube, it's not like going to the center of the cube. And just to show you the difference, if I added in everything, okay, again, right, you can see, I can change this at runtime. This just means, okay, set that back to nothing and set this to ground. This just means the Raycast will not detect collisions with anything that's not part of the ground layer. So this plane is part of the ground layer, and it'll go towards it. Alright, and that way I've effectively ignored the cube. So, what if I wanted to make this like an RTS though, where if I right-click, the unit moves to where I'm going, okay? So, Currently I'm using the left mouse button. RTS controls are usually going to be on the get mouse button down, and they're going to go with the right when I right click. Okay, but now when I hit the right click, see, it only goes a little bit. Okay, and that's because only part of that lerp is evaluating. And I could click it eventually, and I'd get there. It just take a long time, right? When that was happening every frame, it was really quick. So there's a couple ways I could do this. Okay, I'm going to go ahead and open back up the basic move tween, alright? And what we're going to do is we're going to use this script, alright? And we're going to use it to move our units, okay? So, instead of doing this, we're going to go ahead and we still want the same target location, but instead of doing this, we want to say, use basic move tween to move the unit. Ignore that. Let me close Slack. Okay. Anyway, so up here we're going to say public basic move tween move tweener. Okay, and now on my main camera, I have the move tweener. Okay, I've got my cube, and I'm going to add the basic move tween to it. Alright, and the target will be itself. I'm going to say move linearly for now, and we'll say everything happens in 2 seconds, that we don't need to do that, and I'm going to leave everything else the same. So, I'm going to keep forgetting. Save. Alright, so I want to drag the move tweener. So you see what I'm doing here? I'm linking one script from one object onto another. I've got my basic move tween on the cube, and I can get it by dragging it through here. So, alright, basic move tween. We got move tweener. Alright, what I want to do is I want to make a function here. I want to make a public function, and I'm going to call this doTween. Or tween, move, whatever we want to call it. Well, we'll call it move, okay? We'll say vector3 target location, okay? We're going to say the duration we want the tween to happen, okay? And we will also, I guess we could give it a target. We'll give it a target. Okay. And so first I'm going to say this dot target is equal to the target we were given. And it can get a little confusing in code when things are named the same, so I'm going to refactor. I can double tap Control R to do that. I'm just going to put an underscore in front of the one that's part of the class. Alright, and I will say target location is equal to target location. Target position. Don't want to mix these things up. And I'm going to say this dot duration is equal to duration. And again, I will put an underscore in front of this, I guess. Okay, so I'm also going to set elapsed time to 0f when I do this, and I'm going to make private bool move. I'm going to set this to false, and in update, I'm just going to say if move, we're going to do stuff. Okay. Alright, so we need a way to exit this. This is just going to say, alright, if we say move, alright, I'm going to say move equals true. Go ahead and do this math and move our target to the target position, okay, when we need to. We don't want to do this anymore, right? We're not setting the target position because we're not doing it quite the same way. Mover. So this isn't actually the target, right? This is the thing we want to move. And what we want to do is we want to set the mover dot position to the start position plus target position. What we want to do here is say start position is equal to mover dot position. All right. Now this is a lot of code. We're going to make this easier here in a second. So if this doesn't make sense right now, don't worry too much about it. Okay. And okay, so start position and target position. Target position is the target location. Start position is the current position of the mover. and we're calculating the t-val based off of elapsed time. We're resetting elapsed time. We're saying go ahead and do a move. So now we just need to check. If the t-val is equal to 1f, this means if we reached point B in the tween, stop moving. Right? We got there. Destination reached. So here, when I hit, okay, what I want to do is say move tweener dot move. Alright, the target location is target location. The duration will say 5 seconds for now, and we'll say the mover, the thing we want to move, is the unit. Okay? Now, if all goes according to plan, which is always a iffy possibility, I suppose, we should be able to move the unit. So it's going to take, there we go, it's going to take 5 seconds for it to move to where I clicked, okay? So if I only move so far, well, it's only going to go so far. But you see what I've done is, if it takes 5 seconds, it's going to take 5 seconds no matter how far it is. So if it's a really small tween, right, like, that's gross. It takes so long to move that small. We would never do that. Instead, what we would do is we would give it a speed, okay? And we have our speed determined here. Alright, we did this a while ago. And so I'm going to turn this parameter into our speed instead of our duration. I'm going to cross that out and say speed, okay? If we can recall back to physics, you know, speed, or velocity, right? Velocity, we'll say, is distance divided by time, right? It's how much distance you traveled in a certain amount of time. It's your meters per second, okay? And so here, we can calculate our distance we want to travel and the speed at which we want to do it, the velocity, okay? So we just need to solve for t, for our duration, okay? And so duration, okay, duration is going to be our speed times, sorry, it's going to be the distance we want to travel, distance divided by speed is the time, is the duration, okay? So our distance is going to be vector3 dot distance of start position and target position, okay? And speed is the float speed that we passed into this function. So now, it'll move at a constant speed rather than constant time. And this just makes things feel consistent. And because I have this nice component, I can set different movement curves for each of my units. Okay, and you can see that it kind of slows in and make it really wacky. Right. We even went a little bit past it there. Now, I don't know why anybody would ever make something that moves this way, but you could. Just by editing some curves and doing some basic tweens. So, that is a very basic way to do tweens, but let's say we want to do some time-sensitive code, okay? Well, why would we want to do that? So I've always found that this is really annoying. Making this move thing is really obnoxious. And why is that? Well, first off, now I have to keep track of this bool, I have to toggle it. There's so many different things. And I may still very well want this with this implementation I'm going to do, but I'm going to go about it in a little bit different way. I don't really want to check this every update frame. I only want to check it when I actually am moving, okay? And so for that, I'm going to make something called a coroutine. So coroutines in Unity are, they're kind of the best way to do time-sensitive code. So I like to think, you know, we have space-time. We have, you know, time could be a line. All right, we'll call this time. All right, time is nice, and each of these ticks is delta time, right? Delta time. And inside this update gets called every tick, right? Whoa. Didn't want to erase. Update. Delta time, etc., etc., etc. Okay, but what if I want to make my own branch of time? What if I didn't want to do things in update? What if I only cared about this sequence in time? Okay, a sequence, alright? And that's what a coroutine is. It's a sequence. If you want to make specific animations and effects, you're going to do it with coroutines. And so a coroutine is a sequence that runs over time. And this is the logical next step after lerping and tweening. So let's go back here. Instead of moving an update, we're going to move in a coroutine. And coroutines kind of have weird syntax. Okay, they are functions in C#. Alright, and they are functions of a specific type called IEnumerator. And I'm going to make one called moveRoutine. And if I go ahead and do that, you see that I have something. So this is not all code or pass return a value. So I have to return an IEnumerator at some point. But what I actually have to do is I have to yield. I have to yield execution of this function for a given amount of time. Okay? So I could say print hello. And then I'm going to say yield return new wait for seconds. I'm going to wait 2 seconds and I'm going to say print done waiting. Okay? I need to start this coroutine when I call this move function. So I'm going to say start coroutine move routine. Alright, and you see I pass in the function itself. Now that's a little weird, but bear with me. This is actually really nice syntax and it lets us do a lot of cool things. So print move routine. Hello. So we're going to see, when I right click, we're going to see hello, and then 2 seconds later, you should see done waiting pop up. Alright, hello. Done waiting. Hello. Done waiting. Clear that again. Hello. Done waiting. So, we could even say duration. So we'll wait the length of our tween. So when our object arrives, we should see done waiting. Done waiting. Alright, and all this did was wait between these two lines. And so we can do lots of cool things with coroutines. Lots of cool things. And I'm only going to scratch the surface, but actually, in a lot of my scripts, I actually will quite often replace update with the coroutine. And that just gives me a little bit more control. Anyway, so instead of doing this tween here, I'm going to do it in move routine. Here's how we're going to do that, okay? I'm going to say while move, alright? So instead of checking for move every frame with this conditional, it's just a while statement. And so while move is still true, I'm going to do some stuff, and then wait a single frame. Wait until the end of the frame. And there's a really quick and easy way to do that. We say yield return null. This means wait until the end of the frame to loop again. Okay? And depending if I put this at the beginning or end of the while statement, we could do different things, alright? So I'm going to go ahead and delete this wait for seconds, alright? And in here I want to do my tween, okay? So right now I'm going to say float elapsed time is equal to 0f here, and instead of doing this here, okay, so that I don't have to set things annoyingly, alright? Let me just go ahead and actually move all of this code in here at this point, okay? So instead of having to define all these extra variables outside, I can define them inside the coroutine. I don't even need to do this here, right? Whenever I say move routine, I know I'm starting from 0. Okay. So done waiting. So the exact same thing's happening, and you see there's a little bit of a weird thing happening. Okay. And this is happening because I'm starting multiple coroutines at once. So you see, as I right-click, you can actually see hello go up faster than done waiting. Right? That is because coroutines, unlike update, don't block each other. Okay? So it's not like multi-threading in computing, if people are familiar with that. Or it's similar conceptually. You're running two processes alongside each other. They're not really processes. They're just different strings of logic. But they happen in the same thread, if you're curious about multi-threading. It doesn't happen in a separate thread. It just executes all your coroutines. So there is a small performance loss from coroutines, but most of the time I find that using coroutines organizes your code in such a way that it's going to be better than if you had used a lot of stuff inside update. So, what was happening though is, if I right-click multiple times, right, one coroutine will still be happening. So if I go here, right, I said, this is when I click, okay? I start this sequence. Well, what if I click again here, right? Well, right now I'm going to start another sequence. Similarly, I go here, start another sequence. And every frame, each of them is going to execute. And they're kind of going to fight for each other. So what I need to do is I need to simply have a check, okay? And I'm going to do it in here. And let's say, sorry, I can do this with a check, but I can also just stop the coroutine, alright? And I'm going to say stop coroutine. And I'm going to give it a method name. I'm going to give it a string. Move routine. I'm going to stop any coroutine that's running that's given that name. And yeah, so this is a little strange. But you get the idea. We're doing time-specific things with coroutines. And so coroutines, I'm going to go ahead and link some more videos on coroutines, but they're really important, and you should tinker with them early. Get used to the little bit of loopy syntax, and it will make you a much more powerful Unity developer. So, also if you have any questions about coroutines, feel free to ask. Okay. So, alright, what's next? Now, coroutines are nice and all, but what if we wanted to do this in one line of code? Well, we can do just that, and we're going to download an asset called .tween. So I've got the asset store open here. That's Control 9, you can access it from here. And .tween is a free asset, so I'm going to say do tween. I have used it so much that there's a paid version that I have bought, though it doesn't have the most features for how much it costs, though I do recommend it. But the free version is super good. So I'm just going to go ahead and hit import. And ordinarily, I wouldn't try to teach Unity depending on any specific asset. But .tween is, and tweening engines in general, that's what this is, by the way, this is a tweening engine, are so ubiquitous with game engines that it's actually a big surprise that Unity doesn't have one built in. What we were doing with the animation curves and coroutines is Unity's tweening engine, but, you know, it's actually kind of hard to use. So anyway, I imported this. I get this folder called demigiant.tween. So there are a lot of tweening engines, and they all are pretty good, but DoTween's the best. And I'm going to show you how to use it. Almost every tweening engine will look very similar. It's going to give you the chance to make tweens in single lines of code that interpolate a value from A to B over a time t. So to use DoTween in any script, I'm going to say using dg.tweening at the top of my script. This imports the tweening library from DoTween. Alright, and instead of using the move routine, I'm I'm just going to go ahead and delete this. I'll leave this code in here. I'll just comment this out so that if this project gets shared, you guys can still see this code, but I'm going to just go ahead and do this in place here. And instead of moving this with the coroutine, I am going to move it with the tween. And so what doTween does is it adds a bunch of things called extension methods. And extension methods are just saying, taking transform, for example. Transform has a bunch of built-in properties like position, etc. that we have access to by default. Now, it doesn't have access to a lot of other helpful methods. Vector3 is the same way, and an extension method just adds extra functionality to an existing object or class and makes it accessible as if it was part of the base class's API. So what does that mean? That just means now when I say mover dot, I'm going to have a couple of extension methods, and you'll notice that they have this little arrow on them. And these all start with do, meaning they are part of the doTween. Okay, and there are a lot of them. There is do jump, do kill, do local jump, local move, local rotate, look at, move, etc. And we, right now, are going to look at do move. Okay, and now all these tweens are very similar. They have an end value and a duration, and that's all you need to start. We're going to say do move. We're moving to the target location over this dot duration. Okay, and so now without anything inside update or anything inside move routine executing, okay, the cube still moves. However, if I do this thing, I'm going to have weird issues again, okay? And this is because the duration of one tween might be longer than the other. So this lets me easily do what I was going to do with that coroutine, but stop it whenever I'd like. So I'm going to say private tween, okay? And this is something from dg.tweening. You can see it's from dg.tweening here. Say tween, move tween is equal to null. Null just means it doesn't have a value, okay? And then in move, I'm going to say if move tween isn't null, I want to kill the tween. Alright, and that just means stop it. Don't use the tween anymore. And then here, I'm going to say move tween equals this. And so what this does is it uses something called a daisy chain. Alright, it's daisy chaining these tweening functions together. And I'll explain how we can use that here in a second. But at the end of it, at the end of those chains, it's going to return that tween object. Okay, so now I don't have that problem of it like teleporting at the end if I move here and then... Okay, so now it's very, very basic Rts controller. Alright, great. So, what I want to do now, though, is I want to use that animation curve again. I actually lost it. And there's a couple ways I could do that. So I'm going to daisy chain an easing function. Alright, dot ease. Alright, I will start typing that, and you can see set ease. Alright, and now I can give it an animation curve. So I will give it my T curve that I've already made. And right now it's linear, but let's make it like that, I suppose. I always like to make these easier to see. Alright. Well, you can definitely see it has an effect. Alright. Instead of giving it a curve, though, this is something that doTween gives us that's really convenient. We have all of those easing functions built in as an enumerated type. An enumerated type looks like I access it like a class, but I say ease dot, and now look at this. I have flash, in, back, in, bounce, all of these. In, out. Alright, let's say in, out, bounce. Let's see how that goes. That could be tons of fun. Alright, so now it's bouncing. And it looks dreadful. But, hey, it's an easing type. It's an easing function, and you can totally use it. Now, please never make a controller that works like this. So, I'm going to just say in, out, exponential. Okay? This is gonna be a curve like that, but I think it's okay. It looks alright. So what I want to do now is I want to make some routines, and I'm going to make some special effects for where this goes. First thing I'm going to do, though, is I am going to swap back to using this coroutine, okay? And there's a couple things I want to do that. Whoop, sorry, I dropped something. To use the coroutine, I want to make sure that I can exit the coroutine kind of gracefully. Alright, and sorry, you know what? Let's see how far we can go without the coroutine. There's actually a lot we can do just with the tweening edge. So, in move, okay, I'm going to have this whole move routine, and I'm going to set it up here. Let's say that when I move, I want to shake the camera. Alright, so camera shake's a nice effect, and we'll talk about juice later, but it's one of the juiciest things you can do. So I'm going to say camera.main.doShakePosition. Okay, and this is just going to jiggle it and put it back to where it started. And I'm going to give it a very short shake. I'm going to give it a, let's go crazy with the strength, and I'll leave everything else where it is. And it's really just going to be this simple to do an effect for 0.2 seconds. So now, every time I move, again, also please don't make a controller that does this. Look at that. Yeah, camera's shaking. This is dreadful, but, you know, it's, pretty juicy, I suppose. And now, the position's not quite resetting because I'm clicking while the tween's going. But, you know, a really basic thing. I'm going to make this much less jarring and shorter. Let's make it half a second. Then I'll say 3F. That's still, like, way too much. Way too much power. Well, you can play around with the tween. There are more properties. Vibrato. Set that to like 20. Randomness to 180. Or there's a lot of different things I can do. Anyway, camera shake, really easy to do with the tweening engine. We just say camera.main.doShakePosition. There's really no easier way to do it. So now, let's say I want to spawn a ball of stuff and shoot it at the point I was going. And instead of doing it with physics, I just want to move it right there. Well, we're going to do that with particles. Okay, so I've gone ahead and I've imported a bunch of particles already. And I grabbed these from someplace on OpenGameArt. It's called the... oh, what is it called? Flares? Lens flares and particles. So if you want to use these, go check it out. It seemed like a reasonably good pack. Okay, and briefly, we do need to talk a little bit about how 2D assets work. So these are all textures, and I'm going to trim some of these. I don't actually want some of these. And if I click on all of these, okay, you can see they are imported as a texture type. And there were a bunch of different ways that these can get imported. I'm going to leave them be, but when it comes to particles, you may need to fiddle with some of these things. Anyway, so what's a particle? Okay, a particle is a 2D sprite or texture that is constantly pointed at the camera. That means it is called a billboard texture or a billboard sprite sometimes. Billboard just means it constantly is pointed at the camera. So, particles are what lets us make lots of little images and spread them about the screen. So if I go up to Game Object, Particle System, and go over to my scene view, look at that. I have some particles. And particles are a sweet way to, well, I mean, every game ever should have a million particles, of course, but they can be used for so many things, and it's really nice to use them for basic little effects. So what I'm going to do is I'm going to make a ball of particles and shoot it at the point where the ball is going to move, and then after, basically it's going to shoot the particles at it, and then the ball's going to go get the particles, right? Or the cube, in this case. So, particle system, right, is called Shuriken. Alright, that's what the system is called. It is, it's got this like full-sized editor, it's pretty crazy, and you can see that I have playback controls inside the editor. It is one of Unity's best features. Okay, and I have tons and tons of different things to play with. I'm going to talk about a couple, but I will encourage you guys to go and play with it on your own as well. So, the particle system has its origin, which is where the game object is, but other than that, each of these particles has a life of its own. So the first and most basic thing to do is you just want to change the particle that's emitted. And you're going to need to make a material to do this, so we'll call this projectile particle. Alright, and normally we leave the standard shader, but for particles we need to change this. If I click standard, we're going to get this particles, okay? And we're going to see additive and multiply. Alright, and let's just pick a particle. Okay, we'll pick this triangle. Now in this particle system, I'm going to click renderer, and then the material here I want to change to that projectile particle. Okay, so now look at that. I've got my triangles spawning. And now in projectile particle, I could change this to any of these things, okay? And you'll notice that these textures actually are black and white. The blending mode of the particle, okay, if you've ever used Photoshop, there's multiply, additive, all of these things are there. So if I set it to multiply, right, see, look at that. Now the white is going to be multiplied in. This is just, these are essentially blending modes from Photoshop. And however you would use that here, you're going to use there, rather, you're going to use that inside Unity. Now I click on the particle system, and this is really exciting. And like I said, it's a billboard particle, so even though this is a 2D thing, you see no matter how fast I move the camera around, the particles are always pointed at the camera. So, let's talk about some of these different things, okay? A looping particle system is something that will just constantly keep spawning particles. A non-looping particle system is going to emit some number of particles for some amount of time, namely its duration. So I'll set the duration to 1, okay? And I'm going to burst a bunch of particles at 30. I'll burst 30 particles when the thing spawns, okay? Look at that. Alright, and then it's going to... It lasts a second, and then it stops emitting. Alright, so let's set this to 5. Simulate, you see it's going to emit particles for 5 seconds after that. So this emission thing here lets you set a rate, so I could spawn 300 particles per second. And look at that. Woo! Particles! It's kind of gross. Or I could set this thing to looping, and instead of doing a burst, just let it keep spawning particles. Now you see, it kind of looks like it still has this problem here. That's because there's a max number of particles. If the duration is 5 seconds, it's gonna... not duration. This lifetime. This is how long the particles are going to stay visible. Or exist, I should say. You could set other settings to make them invisible, but I'm saying let these particles last 5 seconds. I spawn 300 particles a second, and I can have at max 1,000 particles. So for at least a good few seconds, I'll have hit the max particles, and when there's the max amount of particles, it won't spawn anymore. So that's a performance-conscious option. So if I bump this up to something ludicrous like 10 bajillion particles, I could go crazy with the particles. And never do this. This will probably kill your frame rate on most devices, but that being said, if you find a good reason, I am totally behind people making lots and lots and lots of particles. Set this back down to 1,000, and we'll set this down to like 20. Okay? So, the lifetime, okay, is how long the particles last, and you can see that they all make it about up here before they die. There's a little bit of 3D positioning going on, so it looks like some don't get as high. I could change this to 1, and you can see now they last much less during their life. I don't like the starting color, so I could change this to red. Okay. Alright, that's one thing. Change it to yellow. I could even randomize it. So a lot of these actually have these arrows, which I click. I can set them as randoms between colors and gradients. So I could set the start color between a bunch of different gradients. And now I'm going to be showing you guys a lot of different new little editors here in this particle system, but just tinker. Most of them are pretty self-explanatory. Right, so the gradient editor looks a lot like any other gradient editor. And I'm spawning some like neon-looking particles. I can even edit the transparency if I wanted. But I don't really want to do that too much. Okay. I can say the start rotation, rotate them all. I can say this is random between two constants. I can say between negative 15 degrees and positive 15 degrees, and look at that. Now they're all doing a bunch of different things, and I have a bunch of other different things I can do. So the shape is the size of the emitter, right? So I'm emitting these things in a cone. Okay, this is another most important thing, but I can do this in all sorts of things. If I want a 2D particle system, I would pick one of these two things. I'd pick a circle or an edge. But I could use a box, and I have a 3D box. And I can edit the box. I can drag it around with these little handles. I can edit its Y, X, say 5 by 5 by 5. It's important to note that if I scale this guy, right, if the particle system scales too, not necessarily the shape, though, I mean, it sort of does. They are distinct, though. Anyway, I got a 5 by 5 by 5 box. Instead of them all spawning up, I can say go in a random direction. Alright, and now everything's going to spawn inside this volume and move in a random direction. Say spawn up. I could also do velocity and over lifetime, so some of these things aren't enabled. I could say over time actually go down on the Y velocity. What? Oh. So my thing has been rotated by accident. We'll say 5. So as you see now it moves up over time. These can also be randoms between constants and curves. There are so many little toggles to swap. Instead, I am going to do random direction, and I'm going to change this back to a sphere. I'll make this a really small radius, because I want it to look like the particles are coming from where they are. And I'm going to make my lifetime a little inconsistent. I'm going to randomize this between two constants. I'll say 0.2 and 0.8. And the start size. So I could, tweak that up. Alright. I could leave that at 0.2. I'll randomize it a little bit as well. So easy to do these basic little randomizations that I just always recommend doing it. It makes that little variation so much nicer. So I'm going to bump this up to like 200. Alright, and speed, that's why it's going out so far. I'm going to set that to like 1. Alright, 0.3. Okay, so simulation space is the next thing I want to talk about. There is world and local space. So local space, alright, if I move this particle system around, you see all the particles move with it. Though if I change this to world and move it around, you see the particles actually kind of leave behind a trail. So I'm going to leave this in world space because I'm going to make this a ball of particles that I shoot, and I kind of want it to leave a trail. So now, there are other things I can do. Alright, I can have these guys collide with everything in the world. Okay, and so now kind of hard to see. So this is where I might want to change this guy a little bit, change the material. particles alpha blended. And instead of doing this, you see one of these import settings, this is what I'm going to change. I'm going to get the alpha from the grayscale, and then these are going to work a little bit better. There we go. That's more about what I wanted. That's still a little dark. So I'll set this guy to multiply. It's a little too dark. Oh, no. Well, I definitely don't want it to be additive now, right? Okay, I guess I'll leave it like this. Not the best, but it gets the job done. And you can see that they are sort of colliding, though it's hard to see. Let's bump up the speed again. Right, now they're kind of bouncing off. Bounce. These are all just things that you're going to have to fiddle with. But it is happening. You can see some of them are even bouncing off that cube. I'm going to turn that off. It's kind of an expensive thing. Anyway, let's back up. Speed. Go back down to like 0.2. Alright. This goes along in world space. Looks pretty cool. My favorite thing to parameterize is size over lifetime. Making particles scale out. And you can see there's all these shortcuts, right? These same animation curves are usable in the particle system. Right, and now it doesn't look like they just pop out. So what I want to do next is I'm going to call this projectile. Alright, I'm going to prefab this guy. And I'm just going to delete from the scene. And now inside my here in my basic move tween, I'm going to make a public game object prefab. What I have set up here, by the way, this move tween on one object and this on another, is not the best design from code perspective, but it will let you do basic things pretty quickly. We'll call this projectile, actually. And when I click, I want to instantiate the projectile prefab. Okay, and we will say game object projectile equals instantiate projectile, and we're going to spawn this at the camera and the camera's position, so it's like it's going to come from the screen and move towards where we clicked, which is what our ray did, right? Say quaternion.identity. We're not doing much with it. Okay. And we need to cast this to a game object. Oh, it needs to be capital G. And now here, oops, projectile object. Alright. Now we're going to say projectile object.transform.doMove. Alright, the end value is going to be our target position. And we're going to say get there in, let's see, like 1/5 of a second. Alright? And then what we're going to also do is we're going to destroy that projectile object in like 1/2 a second. Okay, so this destroy lets us take a delay, by the way. I think we went over this in the previous lesson, but just using it again here. So this will let us make a projectile object. It flies towards where we're going, and then it goes away. So now on the cube, I link the prefab. See, now my particles move towards where I was going. And we very simply here made something, it's not much of a game, sure. Again, we're just showing off the basics here, that moves lots of things from point A to point B, exemplifies a great way to use tweens. Well, great way, just basic way to use tweens. We've done it with coroutines, we've done an update, and we've done it with a tweening engine. And we've shown how these can all play together, and we've even gone over Raycasts a little bit as well. So in the next lesson, we're going to go over animations, specifically how we use Mechanism. And that is, again, Once you start describing motion with animation curves and tweens, moving a model or moving a rig is not a big deal, and we'll talk about that in the future.